Hi guys, Sarah here again. We're going to be reviewing the classwork from March 23rd. And again, this is page 41. And so this is number 3 because 1 and 2 we did as part of the do now. So you're given this interesting looking graph of f of x, kind of looks like a snake. And you are asked to transform it by translating the entire graph to the right 4 units. And so what you're going to do, as we have in the past, is you're going to take each point and you're going to move it to the right 4 places. 1, 2, 3, 4, and you're going to put a dot right there. And so what used to be -2, 0 is now +2, 0. We're going to take this local maximum here, which is when x is -1, y is 3, and you're going to go to the right, 1, 2, 3, 4. And so that new point will be 3, 3, when x is 3, y is 3. Let's take a look at this turning point right here. Not a turning point, but it's where your graph appears to sort of flip and rotate. So right here we have 0, 0, which is the origin. And so if I go to the right 4 blocks, 1, 2, 3, 4, and the new name of that point is when x is 4, y is 0. And this one right here, -1, -3, is going to go to the right 1, 2, 3, 4 blocks, and that will become 5, -3. And lastly, our endpoint here, when x is 2, y is 0, is going to move to the right 1, 2, 3, 4 blocks, and so that new point will be named 6, 0. Okay, take a minute. You can always pause these videos if you think I'm going too quickly, and if you don't need the help, just take a quick glance, make sure that your work does in fact match mine. So we're going to start here with f of x, which is the black graph, and so we have this endpoint here of -2, 0. And what they're going to ask us to do for this one is they want you to translate this one down 3 units. So g of x is equal to f of x minus 3. Our k value, our parameter for k is -3. You're going to take each of these dots and you're going to move them down 3 units. 1, 2, 3. Please notice your x value does not change in a vertical translation, only your y. Y goes from 0 to -3. Take a look at this point up here. -1, 3 is going to go down 3 blocks, and his new name is going to be when x is -1, y is 0. And we're going to continue this again. This is number 4 on the classwork from March 23rd. This point was 1, 3. If I go down 3, -3 minus 3 more is -6. 1 goes to -6, and 2, 0 is going to become 2, -3. All right, and that's problem number 4. Okay, number 5. We might have to, if I need you to draw number 7. Number 6, I apologize. Okay, number 5 is a little bit different. We have f of x in red, and they're asking us to do a horizontal stretch by a factor of 3. Now, a horizontal stretch, if you recall, remember what I say in the house, horizontal? Okay, so it's not going to impact our up and down. It's not going to impact our vertical shift. It is only a stretch of our original function by a factor of 3. So again, we're not going to impact the y coordinate. We're only going to impact the x coordinate. And so here we go. So -2, 0, if you take -2 and you multiply it by 3, you're going to get -6. Again, take a look at the y values. They do not change. From x of 2, 0 on the right-hand endpoint, if you multiply the 2 by 3, you're going to get 6. So you get 6, 0. And then up here, if you take 0 and you multiply it by 3, you are still at 0. So again, this is problem number 5. And they're asking for g of x to be a horizontal stretch by a factor of 3. Let's just take a minute and take a look at what happened here. The shape itself has been stretched along the horizontal axis, and so you get this elongation of what looks like a parabola. And although it could be similar to a vertical stretch, a vertical compression and a horizontal stretch sometimes look very similar to each other because they end in sort of the same result, which is sort of a squishing or a stretching of the original shape. Okay, so that's number 5. I'm going to go to number 6. Next, number 6 is coming. Okay, so number 6 looks like this, and I just need the pen here for a minute. Sorry, we're trying to get 7 going, please, for me. This is number 6 on page 41. And so what we have here is x is negative 2, 0, and the other endpoint is x is 2, 0. And right up here, the name of this point, I'll make them a little bit bigger, guys, so it's a little easier to see. And so the name of this point is when x is 0, y is 2. Now, the first thing you need to do is ask them, what are they asking us to do? And so in this example, they are saying stretch the graph of f of x vertically by a factor of 2. So this is f of x. And we're going to stretch it vertically by a factor of 2. So I want you to think for a minute, are we going to impact the x coordinates or only the y coordinates? It's a vertical stretch by a factor of 2. Cap that for me. Vertical stretch by a factor of 2. Sorry, guys. The problem I'm encountering with this stay at home is I only have a certain number of boards. And so we're trying to get this whole page done, and I need 1 board per page. So I'm a little bit backed up. Okay, so we're going to stretch it vertically by a factor of 2. So I'm not going to impact my x coordinate at all. I'm going to impact the y's. And so this point up here, 2 times 2 is 4. Okay, here I have 0 times 2 is 0, and over here my y-coordinate is also 0. So 0 times 2 is also 0, and so we get this vertical stretch that looks like this. It's like you clung onto something and then you pulled it up. So again, g of x is in blue, and what g of x is g of x is f of x times 2. And that gives me, please make sure you have it written out. If you could take a second color here and do the second one, that would be great. Look at the picture, there should be 2. Okay, so again, this is number 6, page 41, a vertical stretch by a factor of 2. Again, we do not multiply anything by the x coordinate. We are only impacting the y. Okay, I don't think I'm going to do every single problem because it's pretty much following the same path each time. So what we're going to do now is we're going to take a look at some of the absolute value functions. But I just want to do a quick recall here. Whenever they say to reflect a graph over x, that is really pretty easy because it's just a mirror reflection. Take this. I need to have endpoints clearly labeled. Make sure you count and match the picture. Okay, so where was I? Okay, that just went out the window. You're feeling my pain, guys, right? I hope you're feeling my pain. All right, I'm trying to enlist my my teenagers' help here to get these done. Oh, I was saying reflections. I apologize. See what happens when you get old? So you're going to take your original graph and you're going to flip it over the x-axis, and so what you get is a mirror image. When you have a y reflection, it's similar, but I want you to think of it as a heart. So a heart usually has a bubble on this side, and when you flip it over, the other side of the heart is formed on this side. So again, whenever I say to reflect over x, and that's some of the questions on the next page, so I'm hoping that you can just figure those out for yourself. They're not terribly challenging. And the reflection, you're just going to go like this, and you're going to flip it over. So when you do a flip, it's not the x coordinates that are changing, it's going to be your y coordinates that are going to change. X stays the same, and the y's sometimes change, depends on where it's located. All right, moving on, can I do 7?
Yeah, I'm confused.
All right, is it okay?
No, because I'm not the numbers.
We're just looking for some endpoints on number 7. And then like I said, no. Okay, Ava, good enough? Okay, so this is problem.
Right on the Y.
Okay, so we said we had some technical issues here. So we're going to take a look at number 7. And Ava, I'm just going to ask you to clarify. So this point is 0, 0. Again, this is number 7 on page 41. Okay, so you work with me here, Ava. Where this dot is right here, give me the name of that coordinate, please. Look on the original, please. I need the name of where the end of that arrow is. Can I have the coordinates of it?
6, 6.
Okay, so it's really over here, 6, 6?
Yeah, 6, 6 would be over it. Well, because I didn't stretch it out.
Oh, okay, can I see the original problem, please? Guys, bear with us for a minute. A little bit of a technical issue here. Okay, so 6 goes to 6. Okay, so hang on, I'm going to redraw this. Hold on one second. 5 goes to 5, 6 goes to 6. Okay, here you go. Okay, so let's ignore this. No, we're not. Do you have a clean board for me, honey?
No. Oh, the clean one? Yeah.
Okay, guys, give me a second here. Some technical issues here. So 2 went to 2, 4 goes to 4, and 6 goes to 6 on your original graph. Black marker. Sorry, guys, this is longer than I want it to be. What do they ask us for, Ava, in the paper? What kind of transformation? I think it was a stretch or compression.
Compress the graph.
So here's, let me just use this moment for like a valuable little like teachable moment here. When you guys are looking at Desmos or you're graphing TI-84 calculators, and sometimes you just go, oh, well, miss, it kind of looked like it was going that direction, and it did, but we have to actually look at the points. So this is a slope of 1 on this side of my absolute value, and this is a slope of -1 on this side of the absolute value. 4 goes to 4, -5 goes to 5, -6 goes to 6. And so that's our original. And Ava, what are they asking us for? Stretch or compression, please?
Compression.
So this is f of x. Ava, I need the full thing, honey.
Compression by 1/3.
Compression by 1/3. Okay. Give me a second. Sorry, this is going longer than it needed to. I'll take this blue marker. Okay, and so f of x, so g of x is a compression. Vertical, horizontal compression. There's a difference. Bear with me, guys. They're asking you for a horizontal compression by a factor of 1/3. Okay. So horizontal by a factor of 1/3. Okay, now remember what I said as far as compressions and stretches. So a horizontal compression is going to be similar to a vertical stretch. And so we're going to wind up with a graph that is narrower or tighter than the given one. And so 2 is going to go to 6, and also -2 is going to go to 6. 2 is going to go to 2, 4, 6, and -2 is going to go to 2, 4, 6. And the reason this is happening, if you recall, I'm just going to do this as quickly as I can here. Sorry for the delay. The reason this happens is a horizontal compression. If you recall, we have that the formula where we said A times the B is in here, and it's always 1 over B times X for the horizontal compress. And so what's going to happen is if you take 3 and you flip it, 1 over 3rd, and you flip it, you actually get 3. And so what we're doing is we're going to multiply each of my X coordinates by 3. And again, it's that inside the house, the opposite of what you think. That same little mnemonic also applies to horizontal compressions and stretches. Sorry this video is so long, guys. Again, I was trying to get as many done as we could. And if you continue to look, I'm not going to finish this page. So the next one says vertically by a factor of 1/2. So vertical is exactly what you think it is. You will multiply all of the y numbers by 0.5 or 1/2 on your calculators. Number 9 asks you to reflect across the y-axis, and so you're just literally going to flip it. You're going to take that circle. Do we have another clean graph, Ava, or no? Do we have a clean? I handed you some, no? Here, babes. As fast as you can. And so number 9 is going to flip. That little bubble is going to flip to the other side of the y-axis, reflecting for number 10 across the x-axis. It's going to look just like this, only you're going to reflect it down, and so it's going to come up down here. Again, I don't have, this is already a longer video than I wanted. Number 11, reflected across the y-axis, so number 11 is going to go something like this. And you're going to reflect it over the y-axis. I hate to do the wrong numbers. 3 goes to 3. And this is number 11. The other ones I'm assuming you can watch and do yourself or just listen to me. And again, you're going to flip this. And so his reflection across the y-axis is going to wind up over here. Okay, so that's number 11. And then number 12 is relatively easy also. It says take it and reflect it over the x-axis. And so number 12, yeah, I just wanted to show that one last one, but my video is going way longer than I wanted it to. So from here, you were up here. Is it 3 again? Yes. 3, 3. And you're going to reflect him over the x-axis. And so you're going to get this down here. 3, 3. Again, sorry again for the duration of this video, guys. I apologize. A lot of questions, a lot of graphs, just don't have the supplies. Okay, we're going to call that a day. And if you have specific questions, guys, we meet every single day, Monday through Friday at 5 o'clock for Google Meet. So that might be a good opportunity for you. Or you can also text a peer and ask them to take a picture of their page and see if your page also corresponds. Everybody, I hope everyone's safe and well. Stay inside. I know it looks beautiful out, but we're just trying to contain what there's already spreading right now. Have a great day. Bye-bye.